computer. Definitely. I hear you, Amber. We don't need anybody to sit back and show off themselves for camera right now. And actually, I've had a different policy as well with stats, but I do check y'all to make sure y'all paying attention. So if you don't mind unmuting the mic so we can freely talk, that'd be beneficial. But yeah, I'm not going to make anybody be on the camera. We all can't be chilling outside like Nyrese, enjoying the weather. Are you at is that at the water fountain? Is that where you are?
Oh, I'm not at school. Cleveland, get over here. I'm at home.
You're not?
No, I've been doing the semester remotely because I've had a lot of home issues with my mom. She got sick.
Oh, no. No, I appreciate, I'll tell you, I'll tell you what's going on. I haven't really noticed that anybody has been going through any hardships. We got a couple students that don't participate in stats at all, but I don't think that's a hardship. That's hard-headed. Let me see. So let me open up these answers and go. You know what? I feel really, really bad. Let me tell you, because as good as I think that I'm, as improved of an educational experience I think I'm able to give y'all, when I looked at the homework, right? Some of these things were, it was kind of going against the best practices that I thought were kind of relevant to what we're doing. I'm going to open up this, then I'm also going to go and get, open a textbook. We'll go to Vital Source. So we can see the homework, we can see the answers, and then we'll also be able to solve any math if we need to get to what we need to. This is what I've envisioned, guys, and I might do this for the next couple of weeks. And now you guys, the 5 who were invited here were the 5 people who essentially handed in the 9.2 homework, right? But I think what I'm going to do is come to the people who are leading, right? If you guys get any points off on homework, as long as you guys come here and you guys are willing to kind of learn about what you did wrong and then be willing to conduct a class on Monday. Like you guys know, I don't have class on Monday, right? It'd be an opportunity for you guys to give back to your peers, to jump in there and kind of show them exactly what it is that they should have done for the homework. Now, let me tell you, I kind of sort of wanted, like an ideal world, it would be perfect if we did this with not the actual homework problems, right? But the problems from the essence of statistics. But I, with the time and this being on a weekend, how we're doing it, I don't want you guys to have to work out and do any additional math problems, right? So the essence of statistics has problems that are very similar to our homework, but with different math, right? Now, again, I can sit back and be like, well, if you know how to do it, you can do it with different math, but I'm appreciative of what you guys are going to be able to offer our students if we do this. So I'm not going to make y'all do any additional work. We'll just look at exactly what they should have done. It's already late. People that come in and learn from what we're doing, they'll get credit, but they won't get what you guys will be able to get. You guys don't have any late penalty. Those who were here and identified to do like a little session like this would get a perfect score on any items that you may have lost. With, in my mind, I would say minimal work. You know what I mean? Minimal work, because all you're doing is going back and looking and seeing what your mistakes are, and then being willing to kind of repeat what you think you know. And one of the things I've learned from Essence is that you may think you know it, but you don't realize how much you don't know it until you're challenged with trying to teach somebody else. And I think if you guys are willing to sit back and take some items and bring them to the class and kind of struggle through them, it's not going to be easy. It's not going to be pretty, but you really will grasp the content after that. And that's the kind of point that I'm aiming for with this activity. Since we got Mondays off, it's a great opportunity to do that without losing any time. Okay, so let me see if I can make sense out of all this stuff, right? All right, so 9.2. I think I gave some names to the people who were assigned this via the email. Let me go open that up too so I can speak mine appropriately. Boom. And we can switch these things up too if anybody's feeling like they would be better pressed doing it. And also, I don't want people to feel as if, all right, that's Nyrese. If Nyrese is up there struggling, that's on Nyrese to struggle. I'm not here to help her. You know, I think we all should be somewhat comparable and competent so that we can help each other. Because again, you might turn around and need that same exact help as well. Let me see what I wrote to you guys about how I assigned you for each problem. Teach lecture should be in here. All right, let's do Sunday at 2. All right, so we had Jasmine. All right, for number 1 isn't even here. All right, so that's good, but we'll sit back and go over this, right? Now, for items 1, A, B, and C, right? Essentially what we're doing is this. Which of the following involve independent samples, right? Now, I had a definition that I brought to you guys this semester that I really, really enjoyed, right? I thought it was very beneficial. However, this textbook being obnoxious, they actually found arguably some of the unique situations in which my definition wouldn't necessarily work, right? According to the textbook, and I've looked at this and thought about it really, really hard, the first example is dependent, right? So let's look at what that's saying, right? In Appendix B includes pairs. Let me make this a little bit. I see you leaning in, Nyrese. See if I can make this a little bit bigger. All right, data set, blah, blah, blah. Again, I wish we could just get rid of that stuff sometimes, right? Pairs of ages of actresses and actors at the times they won Oscars, right? For Best Actress and Best Actor categories. The pair of ages of the winners is listed for each year, and each pair consists of ages matched according to the year that the Oscar were won. Right? Now, let's look at what this answer is. The answer to this is that they are dependent, right? Now, a lot of people put independent, and I'm going to tell you why. I think why. When I sat back and talked about the definition that we use, it really was that they should be like kind of intimately connected, like brother, sister, twin, husband, wife, et cetera, right? Now, if you take that situation 100%, there's no intimate relationship between these things, right? The actor and actress are in different movies, different studios, different roles, right? So what is the pair? The linking to this really is, I'm gonna sit back and start drawing on this. The linkage between these two is the fact that they were listed for each year. And to understand that, you gotta kind of get out of the focus of the actress and the actors, but they were paired according to each year, right? Each pair consists of ages, that's the data we're looking back, according to the year the Oscars were won. Now, that's not like brother, sister, that's not twins, not husband, wife, but there is a dependency based on the fact that we're listing our data according to years. And, you know, I think with the activity that we did to make y'all understand them, this is one that really slid in and might have distracted people. And again, I'll tell you that in my mind, this is what I don't like about academia. Academia likes to sit back and teach you A, B, and C, right? And then we want to test you on like F and G. And as faculty, we get happy because, ooh, see, I taught Siani ABC. In addition to me teaching her that, she was able to, on her own, make connections that are meaningful, that are this, that are that. And she made a connection to F and G. I don't like that at all. And I think it's hypocritical. We need to teach you what you need, as opposed to trying to teach you the basics and then test you on a higher level. So again, that's the issue of why that is dependent. It's because they were categorized according to each year. Anybody not understand that? Want me to elaborate a little bit?
I just have a question, Dr. Burns. So you
Okay.
said basically it would be dependent because they were paired by year, like each year.
Yep. That would almost be like this. And what I mean by this, let's say we have a little chart and we're going to look at the people who won the Emmys in 1921. Then we're going to look at the ones from 1920, 20, then we go to 2019. and then we have them for 2018, right? And essentially what we're going to do is we're going to sit back and have, we're going to list the male and then female, right? I'm sorry if you can't see that, right? But again, when we do that, the reason how they're being paired is because of this relationship right here, right? This right here is a pair according to the year 2021. This right here is a pair according to the year of 2020. And this is a matched pair consistent to this, right? So this is how they become kind of a matched pair, which makes them a dependent sample. And honestly, it does. It takes kind of drawing this out to be able to see it. But I just feel bad because I think the definition that I gave y'all, I think was a really good one. But this definition just really exploited it because there really was no real world relationship between the male and female actors and actresses. And when you get into it, different movie, different role, different studio, different script, like oh, there's so many different, but at the very end of it, because of this focus on the year, they are dependent. Does that help?
Yes.
Yes.
All right, okay. All right, so let's go on to the next one, right? Next one is with presidents. In Appendix B, they include the heights, right, of elected presidents along with the heights of their main opponents. The pair of heights is listed for each election. Again, this is another one that really exploits that simple definition that I gave y'all, right? Pair of heights right there. Now, the same thing, you would probably sit back and think about this. You got to think about these elections that came out. This was, wasn't it 2020 was an election?
Yes.
Got to go back to 2016. If we go all the way back to the last time we had Obama. No, wait, no, I skipped one, my bad. And then 2008, right? So we got all this here, right? Now, according to this, we're talking about the heights elected of the person elected presidents along with the heights of their opponent. So in a similar fashion, right? We would have, I'll say winner, just to sit back and make it clear, and then loser. I was gonna say that, right? So we have that. Same thing, when you lay it out like this, when you realize kind of what you're mapping out, we're comparing them, it's being paired as a result of the year that you're doing or the election that's being done. Again, I understand people got these wrong. I think the definition I gave is a really good one, but you know, remember I sit back and say all the time, we got to use critical thinking. You really have to. This author is obnoxious because they went out and they tried to find a definition and an example that really does exploit any simplistic understanding. So I get that people got this wrong. And I think this little explanation of what we're saying right now might be helpful for us to kind of relay it to the group when you guys do this on Monday. Let me see. Then the last one, we talk about data set, COLA weights and volumes, right? In Appendix B includes the volumes of the contents in 36 cans, right? So we got 36 cans of Cokes and the volumes of the contents of 36 cans of regular Pepsi. Now, I'll be honest, I don't think many people got this one wrong. This was one of the few that, even though they got everything else wrong, they got it. It's because you guys, I can't see any pairing. You know what I mean? There's nothing that would sit back and say, I should compare this Coke with that Pepsi. It wasn't there. But these first two were wrong a whole lot. So if anybody wants me to elaborate on it, I definitely can. But I think this was one that was, I think, a little bit clearer. But again, I want everyone to be competent. I don't want anyone to feel uncomfortable Monday. So if you want me to elaborate or maybe do a graph or something, I definitely can if you want.
No, I get it.
All right. That sound like Kevin Hart, my bad. All right. Now for two, we did 2A and 2B, right? So let's see what those problems are. Okay, 2A, 2B. All right. Confidence interval for hemoglobin. Large samples of women and men are obtained and the hemoglobin level is measured in each subject. Here is a 95% confidence interval for the difference between the two population means, where the measures from women correspond to one population 1, and the measures from men correspond to population 2, right? So here's the issue. We got to focus on what's important right here, right? And what's important right here is this. Now, does anybody know what we can tell from looking at a confidence interval? Does anybody remember what this range should be, right? Now, this range right here is here, and then that. So let me just draw this on the piece of paper down at the bottom, right? We got, let's say -2 is right here. Say we got -1 right here, and we'll have 0 right there. The confidence interval, where we are confident, right, that the hemoglobin from men and women, when we subtract them, we're not 100% sure, right? But we're 95% confident that it's going to be somewhere between this region right here, I'm going to say. Let's imagine that this right here is neatly, let's say this is -1.76, the top part, and this is -1.62. We're 95% confident that the difference between those two is going to be within this region, right? Now, looking at this confidence interval is important because looking at this confidence interval can tell us how it's significant or whether it's significant or not. Does anybody know what we look at or we attend to find out whether this difference is significant?
Is it like, I'm sorry, T critical value?
You know what? The T critical would be when we're actually doing the T test. But the confidence interval itself has its own test that allows us to determine whether or not something is significant or not.
Isn't it if it has a 0 in it?
Yes. Now, you know what? Now look at this right here. This right here is saying that the difference between the hemoglobin of population 1, women, population 2, men, right? It's when we calculate those differences, we're sure, we're 95% confident that they fall over here, right? Now look how far away that is from 0. 0 is way over here. Now you got to sit back and think about what we're doing. We're always saying that they're the same. If two things are the same, and we subtract two things that are the same, the value is going to be 0, right? Yeah, we subtract 2 ages of anybody in this room and their age is the same, it's going to be 0. Now you can have a little bit of wiggle room. I do this a little bit with like Siani and Naris, right? Both of y'all are students. I'm gonna say y'all the same age, right? And both of y'all tell me that both of you are, I don't know, 19. You'll say you're 19, right? But Naris is going to sit back and say, I'm 19 in 6 months. Siani's going to say, I'm 19 and 1 month, right? Now, if I subtract their ages, it's not going to be perfectly 0 because they talk about the 6 months and the 3 months, right? However, the fact that our confidence interval says that when we subtract Naris's age and Siani's age, it's over here. And the wiggle room that I get of the error as a result of like maybe some mistakes I'm doing, it doesn't even include 0, then I would sit back and say that Naris and Siani are different ages. And that would be the case, not for 19 and 6 months and 19 and 9 months, right? But imagine Naris says, I'm 24, and Siani says, I'm, not to insult anybody with their age or something. No, Siani says she's 29, right? We subtract 29 from 24, that 5-year gap, right? It would not overlap with 0. So we would confidently say Naris and Siani are different ages. But since Naris, let's say 19 years old in 6 months versus 19 years old in 3 months, when we calculate that, it would more than likely cover up this region right here. And the region between separating those ages would be right here. And nobody would bet their money or their reputation on the line that they're different, because the difference that we calculate between Siani's age and Naris's age it includes 0. So that's really what, it's a different way of looking at it. It's like you take two things, subtract it. And if what we subtract and we create a little confidence interval, if that confidence interval does not include 0, right? Just like this right here, then we'll say they're significantly different. Not just different, but significantly different. But if we were to take those differences and it does overlap with 0, then we would say, nah, Siani and Naris, I know y'all weren't born on the same exact day. No, you weren't born, with the next day afterwards. But we can't say that there's a significant difference in your age. Both of y'all are 19. There's no reason for you to be like, I'm older than you, I'm smarter. Like that argument doesn't make any sense, right? So I think you guys can see it with age. And I'm hoping this example right here can help y'all understand why the confidence interval says, if we get a region like this, and when we look at this region, it does not overlap with 0, we'll say there's a significant difference there. But if we did have this, imagine this right here was plus, right? 1.76 and then positive plus 1.76. That would mean that the region, I'm gonna use it with the green color. That would mean the region would be here. It would go all the way over to probably, all the way over to here, I'm going to say, right? And then our region would be, this would be our confidence interval region. It's a little bit bigger than the one that we have, right? But this would be the region that we would have. Since this region, right, actually overlaps 0, then we would say no. So I hope that, that's a quick way of doing it because I feel like you guys have probably seen it a little bit before, right? But that's just my way of trying to summarize it up with, I think, a concrete example. Anybody want some more understanding? Okay. So let's look at this problem and see what it's really saying, right? What does the confidence interval suggest about equality of the mean hemoglobin level, right? It's suggesting that they are significantly different. Now, the only thing I would like for you guys to know, and I think you guys can say this now, is since the difference between men and women is so great that the confidence interval does not include 0, that's why we say it's significant. Okay, 2B, write a brief statement that interprets the confidence level. I think a lot of y'all got this right. So let me just sit back and look at how the textbook told you how you guys want to write this, right? And you say it along the lines of this. Annotate, draw, right? We are 95% certain, that's because our confidence interval is 95%, that the difference falls between negative 1.76 and negative 1.62. That's how we would write it. There's a page in the textbook that goes into that. Let me see if I can find that page just so you can go back and look at it. Clear this.
No, stay.
So how are you able to work from home, Naris?
When in regards of school,
Mm-hmm.
at the beginning of the semester, I looked at my schedule that I already had placed and I emailed the provost and all my professors and we figured it out. I had to switch out of some classes, but I don't think I emailed you because I know it didn't apply.
Yeah. And you know what, honestly, I'm not sure if you heard my question right. I was just saying, like, how are you able to do it? Like, are you comfortable? Things good?
Oh, yeah, it's nice. I actually moved into my own house, so I kind of live with just me and my roommate and our puppy.
Oh, when you said home, I'm thinking you're at home. That's funny.
I am at home.
No, yeah, but I mean like home with like mom and dad. Why y'all put so much responsibility on y'all? Like you really have your own home? I'm not trying to get in your business, but good grief.
Yeah, we have a 2-bedroom house.
Okay. How much you got to work to handle that?
Well, since it's Greenville, the cost of living is not as expensive, so I think we pay $550 for rent, and then like our other means like Wi-Fi and stuff our landlords are also like really good family friends, so they help us out a lot as well.
That's awesome. You know,
Thank
you go exactly against what I did. My whole logic is sit back and sacrifice when you're in school. Then when you get out with a full-time job, that's when you splurge.
Oh, well, I'm not splurging.
You got your own. Okay, living in a dorm is not splurging. What you just described, I'm sorry, that's splurging. But again, it's all to what people expect, I guess. I actually don't see how it says to write out the confidence interval. That might have been in the previous chapter. I thought it was a section that actually told you and showed you how to write them out. That's frustrating. But everybody got that right. And if you guys need any assistance, just please reach out. Okay, let's see what the next problem is that we're going to go to. Next is 3A, and I remember this question. It goes back and it's consistent with the textbook. When it comes down to doing the critical value, p-value, and then also doing the confidence interval, sometimes they use different standard errors, which is mean like the standard deviation, the is the different or it's the same. I'm going to try to show y'all what makes it so that these are able to be used. I think it's under a section called equivalent methods. Yep, right here. This section right here is saying equivalent methods, right? The p-value method of hypothesis testing, the critical value method of hypothesis testing, and confidence intervals all use the same distribution, meaning that they're both using like the t-test distribution when you use the back of the book, the appendix, right? So that's what this means. When we say right here that it's the same distribution, we are referring to the distribution that we use in the back of the book. And sometimes you probably don't realize it, but when we're doing a t-test or a critical value, make it a confidence interval, you might be looking at something else, right? And it also says, and the same standard error, right? So they are equivalent. So again, if you're doing the same data in the same test, just doing it a different way, and all the information that you're using is the same, it's going to be equivalent. And I also want to show you what I mean right here by the standard error. Let's hope this works before I get y'all a little mixed up, right? But looking at this right here, right? I want you to focus and pay attention to this right here. This says S sub 1 squared over N1 plus S sub 2 squared over N2, right? This is what we're using to create a confidence interval, right? That right there is key. That's kind of our standard error. Standard deviation is like our measure of standard error, how things differ from each other. Now what I'm going to do is I'm going to go back to the previous page, which gives us the equation for when we're doing the hypothesis testing. And that's when you'll either do p-value or you'll do the critical value. Actually, hold on. Let me see if I can move it. Can I move it? Let's move it. What I highlighted in the confidence interval, that's exactly this right here. S sub 1 squared, S sub 2 squared over N sub 1, right? That's like our denominator. So that's the reason why they are equivalent, because we're using the same distribution, we're using the same appendix from the back of the book, but also these equations are using the same standard error. And the fact that this is the same exact, now, if this was S sub 2 divided by N squared minus 3 or something, then it wouldn't be the case. And we might get different answers. But since what I circled right here is exactly what I circled in the other, both equations, both approaches have the same standard error. And that's the real reason why they are the same. And I hope that whoever is comfortable saying that would be willing to talk about those two equations, either write them out, let the class know that's the reason why they are the same. I don't think the textbook did that at all, but if we're trying to help our peers, it'd be neat if you guys could point that out. And again, it's on the recording, so if anybody's like, what did this Dr. Barnes said? All right, any other questions? Anything people want to go back so far?
Wait, I have a question.
Mm-hmm.
Is it only gonna be me, Amber, and Siani tomorrow?
You know what? I believe it should be, unless I hear from Jasmine, unless I hear from Deja that they have watched the video, they're understanding and they're willing to participate. I think we should go with the three of us that are here because you guys are here. Like I might record this and give it to you, but I actually don't think. I'm going to do this more often, right? I think that what might happen from now to the end of the semester is that Mondays are run by you guys going over homework to help people get stuff caught up in a very similar fashion. I don't know how many people are going to be here. Y'all might be preaching to an empty Zoom, but I think it will be beneficial for you. And maybe I'll record it for the rest of the class. You know what I mean? Like so that they can look at what you guys are doing. And after homework's already due, they can find ways that kind of address the issues that they occur. But I think right now for this, I would probably say it's best for us to make it so it's just you guys.
Okay.
Okay, so honestly, we're almost done because the questions that we have, we go from 1, 2, and then 3, and then 8 and 10. I'm going to tell you, 8 and 10 are identical, right? They're just different word problems doing the same exact thing. I'm sorry, I'm eating some chips.
Cleveland, don't go where I can't see you, please.
I'm gonna send you an Amazon thing about what you probably need. How much land you got out there? Sounds like you got a lot.
We have like 2 acres.
Yeah, you probably don't want to tie down it. Well, we got a tie down in the middle of my yard, and it's about 40 feet. He can go pretty much anywhere in a circle. And,
See, we had a runner, but we took it off because he's just, he's usually good about where he goes, and he usually comes back.
I had to chase my dog to my neighborhood one too many times. That's why I stopped it.
Yeah, it's probably
all the race relations that was going on. I'd be scared to walk into my backyard and they'd be like, "Excuse me, N-word, what are you doing on my properties?" I was like, "Yeah, let's time down."
Same. I'm the only Black person in my whole neighborhood.
Well, you had trees. I just kind of assumed that. All right. So let me blow this up a little bit.
You said I have trees, so you assume that.
You know what? And actually, I mean, that sounds ignorant, but you know what? There's research on that. A lot of African Americans, we don't have properties where we have trees. Yeah, I think it's somewhere between, it might change now because that's talking about what I did in grad school and recent stuff, but circa 2016, I think there's probably only 20% of African Americans who own property that actually have trees.
I heard about that too.
Yeah. Yep. And I had to correct myself just for not recently being like, Dr. Barnes is ignorant.
No, it's true. My friends won't come and visit me because they don't want, it's a long story.
You know what, though, I'll tell y'all. Yeah, you know, I'm not going to say that. The fear of the lack of diversity, it's real. You know, and I'll tell you this, I can't give people my solutions of how I navigate life because, like I said, I'm a doctor. I know how to talk to police. I know how to talk, like people sit back and say like, you know, like white voice or whatever. I'm comfortable doing it. So I know what works for me doesn't work for everybody.
Yeah.
But I feel safe no matter where I am. But I'll tell you, I went to a conference with some of my colleagues. They still go to this university. And we got pulled over by a cop. Let me tell you, I couldn't believe that Black faculty members my age were like fearful that this cop was going to kill us. I talked and got right out of the ticket and everything. They almost made it seem like you're lucky. I'm like, I'm lucky? Are you kidding me? Like I never had thought my life was in jeopardy. But enough of that. Let's not get into this. Okay, now problem 8, color and cognition. Researchers from the University of British Columbia conducted a study to investigate the effects of color on cognitive tasks. Words were displayed on a computer screen with background colors, also just the background colors, of red and blue. Results from scores on a test of word recall are given below. Higher scores correspond to greater word recall. Right now, some key things that are relevant. Use a significance level of 0.05 to test a claim that the samples are from populations with the same mean, right? Construct a confidence interval is the next task. Construct a confidence interval appropriate for the hypothesis test in part A. Why is A in brackets? It's kind of weird. What is it about the confidence interval that causes you to reach the conclusion from blah, same thing. And then C, and I don't think I usually have people answer. Does the background color appear to have an effect on word recall scores? If so, which color appears to be associated with it? You can figure that out right now, but let's go through and kind of play with this. I'm going to do a print screen so I can put this in Paint and we can go and play around with this on a PowerPoint. All right, blank screen. That is not what I just copied.
She a runner, she a track star.
I don't know why this is acting like this, but I'll just deal with it. Oh, wow. Stats 2. Sorry, guys, y'all seeing me like getting stuff set up that I know you don't need to attend to really, but it's just help me have a visual on the screen for us.
I think you need to go through your files.
You know what? Let me tell you. I look at my colleagues. No offense, but yeah, I know exactly where everything is. I've done this just recently. I just bought a flash drive today, USB 3.0, and went through to make sure that I didn't have anything that was deleted. I might have got rid of maybe 20 folders or stuff, like projects that I was going to do in the past that I realized I'm not going to do anymore. But it's all here. Yep. And it's really good because I can sit back there and show you stuff that I have from, or communications from people and things I've done for as long as I've been here. It works for me. Okay, so let's use a significance level to test a claim that the samples are from populations with the sample mean. Now, the first thing I think that's really key on this, if you look at the homework, the answer that I have is I wanted people to kind of list the hypothesis. Now, I realize I think in all this, it's not kind of listed, but we that's the first thing that we want to do. Let me, ooh. Are y'all able to see me?
You?
No, to see the screen?
Yes, we can see the screen.
Okay. All right, so when we do this, do y'all know what the hypothesis should be? We got the hypothesis, and then we got the null hypothesis. I'm sorry, the null, and then the alternative. Do you know how they should be? This is going back a little bit, so I don't need y'all to feel bad if you don't remember it.
Is the hypothesis basically saying that like the one is not equal to the other, and then the null is saying that they're equal to each other?
You know what? Yes, right? There's two ways of putting it. There's two ways of putting it. You could say mu sub d, right? Because remember how in this, we always get these scores and then we sit back and we subtract them from each other, like the male for the female, the male, right?
Yeah.
It could be mu sub d equals 0, or it could be mu sub d does not equal 0. But I want you to realize, I'm going to do it right now. I'm going to show you that this is almost the same thing, right? That's almost like saying mu sub, what is this? Is this men and women? No, red.
And blue.
Right? And then mu sub blue, right? Mu sub blue saying 0 is just like saying red minus blue equals 0. That's what we're doing. We're going to sit back and see what the recall is for red versus the recall is for blue. And since they're equal, they should be 0. So these are two different ways of saying the same thing. You guys get that? Does that make sense?
Yes.
And the same thing would be true for this right here. If we're saying, no, it's not the null hypothesis, because the null hypothesis says, look, everything's the same, no big deal, right? We're doing mu sub r minus mu sub b, right? And we're saying when we subtract those, it's not going to equal 0. And that would be the case if we're doing something real funny, like, I don't know, the reading of air is like 24 words, you'll remember, right? 24 words minus 32 words, right? That does not equal 0. That definitely does not. But if we sit back and see that they don't have any effect, that means you get, remember 24 words when it's red, and then you remember 24 words when it's blue. That equals 0. There is no effect there. It doesn't matter what color the background is. And that's just kind of like the overlay understanding of what it is that we're trying to do. We can do that. So this right here is step 1. To write out the hypothesis. That's just kind of like one important point.
What is that saying, that red minus blue is not equal to 0? Is that all it's saying?
Yes, but we got to, to understand more of what it's saying, let's go back over here, right? Look at this problem. They conducted a study, say that we're trying to look at the cognitive effects of background colors. So the only way I see this is being able to say anything more. That's saying the mean words that you recall in a red background is equal to the mean words that you would call with a blue background. And since they're equal, that's why it equals 0. Is that what you mean by what does it mean, or what is it saying?
Yes.
Okay. I just want to make that, because again, I think sometimes I can go off on like these real long tangents. I'm trying to talk real to the point so I can get y'all what y'all need. Okay. Okay, so let me get out of here and go look at the next thing that we want to do. And this is also looking at the homework. I think all of you guys have that homework, right? The next thing, writing out the null hypothesis, right, was to find out the T critical. Like, what's that T critical value? Now, there's a couple bits of information that you could sit back and attend to, right, to find out what the T critical is. For t-test, we need to know significance level. We need to know N. And I believe that's it. Significance level and N. Now we need to know the distribution, but again, we're doing, what type of test are we doing? Do you not know what, are we doing a Z-test, a T-test, a T-test? What test are we doing?
T-test?
Now you said T, right? T as in Tommy?
Yes.
Yeah, we're doing a T-test, exactly. Right, so let's get out of here. Let's go look in the textbook, because I'm kind of already there. I wish I knew what page number it is, I don't. Let's go over here to the textbook. I'm going to get rid of all this notations because we're on to something else right now. All right, so let's go to the appendix. We go to these tables. Now, is anybody comfortable with writing on the screen? I know I've gotten real comfortable with it, but are any of you guys comfortable with writing on the screen when it comes down to like writing equations like I just did?
Never had to do it.
Never had to do it. Okay.
Yeah, I've never had to do it either.
Yeah, I never had to do it.
We're gonna have y'all play a little bit. We're gonna have y'all play a little bit today, see if y'all can do it. I think it'd be neat if you guys are doing it. Now, what I think I'm gonna try to do is this. I'm gonna do what I did. I kind of cut out some pictures for y'all. Remember that little word problem? I think for all these problems, I'm gonna create a little PowerPoint that has all the homework problems on it. So that if you guys are uncomfortable kind of talking through the answers and what you guys got to the answers, then on that problem, if it's kind of shrunk up to the side, you can draw on that slide, kind of like I was doing. But I'll make sure that we can do that before we leave. I at least want to try to get out of here by 3:30, if that's not too much time for y'all to keep y'all here.
I don't know, Dr. Barnes.
All right. So, oh yeah, the other information we need as well is the fact that we're doing a one-tailed or two-tailed. Now, I'll tell you, I know that we can tell whether it's a two-tailed test from the hypothesis, right? Because a hypothesis that's two-tailed is going to be written kind of the way that we had it. A two-tailed hypothesis is always written with mu, like it equals something. Right? It could be any value. I'm going to say mu equals, I'll say 10, right? And a one-tailed test would be mu is kind of less than equal to 10. Now, the way that we wrote our hypothesis before, it definitely was mu sub d equals 10 or equals 0. So we know it's a two-tailed test, meaning we can look anyway. It can be greater and it can be less. Travis, tell your brother to come down here and finish y'all chips. And you too. Sorry, guys. So we definitely want to use a two-tail, right? So let's go back and think about what we had from the previous information. We know we're doing an alpha of 0.5, so it's either here or there. Our n was, oh man, y'all remember what it was in the last slide?
Was it 35 or 36?
Yeah, you're right. I can 30. Yeah, it's actually 35 and 36, right? Now, what we end up doing is this: we take the smaller one. We take the smaller one. If you have mixed samples that don't match up, we always take the smaller one. Right, so let's go down here and look at the 35. So we're going to be looking at, it's two-tailed. So we're going to be looking at this column. You can't see the heading, but this is where the 0.5 is for two-tailed. So we're going to go all the way down to this row of 35, and that's what we want to pick. .030.
Wait, you said we go down to the row of 35, 2.0. Oh, okay.
Okay. Yeah, let me know. Again, I think I've made mistakes before. I just want to make sure we get it right. Now let's see if, oh, and there we go. 20. Wait, hold on. Okay. Now, you know what? Y'all need to hit me upside the head because I messed up. You know why I messed up? Because degrees of freedom, I looked at n, right? But I went on this chart and did degrees of freedom, right? So N is 35 for the smaller group, but how do you get degrees of freedom from N? Y'all remember the little equation that we always use?
N minus 1.
N minus 1. Yep, so I made a mistake right here, guys. I'm really sorry. Hope I'm not gonna lose y'all with like, it don't make no sense. But that's why we go to row 34, because it's N minus 1. N minus 1 is the answer. Right, so these are two things I wanna make sure we can do. We wanna make sure when we go to this, clear all drawings. First thing we wanna do is be able to write out the null hypothesis. The next thing is go to that table and find out what the T critical is. And I messed up, but hopefully y'all won't mess up, right? The next thing is then really to plug in the numbers and solve the math, right? And this problem actually made it really easy for us because look at these values, 15.89. Let me clear this. These numbers, every number that we need was actually already given to us. So we didn't have to do any calculations on our own. It really was there already. 10.3. This is problem 8, right?
Yes. We only had to do problem 8A, right? Yes.
Actually, no, and that's kind of the reason why a lot of people didn't do well, because they did 8A, which was significance level of what I'm doing right now. They didn't do B, and B was the confidence interval. That's why I think a lot of people did that. I think what I'm going to do, and I've already done it, but it's too late for y'all, is I'm going to tweak the homework so that it clearly says that. So if you look at the handout and it asks you what question is, it will say 8A, 8B, so that we won't have people who kind of just stop doing it. And that could have happened from a number of reasons. Maybe just got distracted. It is a long problem, I'm not going to tell you. Not going to lie, it takes a lot to go through these couple of steps. But the numbers we need to do that are all here. The X bar for the blue and then the red are here. And then S for the standard deviation is all right here. And those values will all be in this equation right here. The 35 to 36. And then it's just a little simplistic number crunching to get the value of T. And this value of T is what we actually get. And that number is right here. Now, this right here is actually kind of sloppy. So I'm going to recreate this. I'm going to recreate this so that it's probably bigger for all of us to be able to see. All right, blow this up bigger. What I try to do there so that everybody can see at least what I kind of asked for to be clear on these things are this. We got our distribution. I guess I could just do the distribution like this. Now, our critical value, right, which is that kind of region. Do y'all remember the value we got from that table?
2.030.
2.0.
It was 2.032.
Yep, there we go. And again, that's Naris. I'm not going to say anything about you because I gave you the wrong one first, right? But it's 2.30. Now, what you got to kind of always remember is since we're doing a two-way, it can go both ways, right? So over here, this value is 2.032. And over here, it's positive 2.032. Where y'all gonna go? Oh, just move it. Okay, never mind. I'm sorry, guys. All right, so this is our critical region. right? Then we have what we calculated. We calculated the value and we got a value of, what was it? 2.62. Y'all gonna make me lose my mind. Up in here, up in here. Let me go back to this.
It was 2.648.
2.648. Okay.
Oh,
2.6. Four, 8, and it was positive, right? So we create our critical region. If our value is in this critical region, what would we do? We're going to reject the null, or we're going to fail to reject the null. Oh, that's a real question. If our value is in here, between any of this,
we would reject it, wouldn't it? Wouldn't we?
if it's in this green area, if you're looking at the screen with me, if it's in here, no, we fail to reject, right? Because this goes back to what I was saying before. Remember I was saying like 0 is dead smack in the middle, right? And if the if reading with a blue background and reading with a red background, if there's no difference, right? Then when you subtract one from the other, it would be 0, right? And so we created a region that's saying, look, it doesn't have to be perfectly 0. Which is just exactly what we said, like Siani's age, 19.3, Nyrese, 19.9, right? And we look at the calendar. It don't have to be perfectly 0. But if it's anywhere within this wiggle room and includes 0, then y'all basically the same age, right? Now, when we go and we find this T critical right here, what we're saying is, all right, so what is the region in which we're going to tell ourselves, no, 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 no. If we get something beyond this value, we know it's not the same. Not only are you guys not the same age, but you guys are significantly different. So if it's in this green area right here, it actually, I'm going to sit back and make this the green area, right? If it's in this green area right here, we fail to reject the null hypothesis, right? Because the null hypothesis says they're equal. We fail to say, nah, we think they're different. If it's in this region out here that's red, that's critical, right? That's when we would sit back and we would reject the null hypothesis. And the value that we have is 2.648. 2.648 is, this is probably 2. That's probably somewhere like right, I'm just going to draw this right here. 2.648. Now, y'all can see I wrote it in the color red, which is probably going to help you. But since this value is in that critical region, yeah, it's clear as day that we will reject the null hypothesis. When people are reading between a red background or a blue background, there is no significant difference. That makes sense for you guys?
Yes.
All right. So now that is everything that's needed for what do you call it? That's everything that's needed for
9.2.
8.8a. I think that's everything that's needed for 8a. The only other thing would be just stating that, you know, it's you reject the null hypothesis because it's in the critical region. Test the claim that blah, blah, blah. Next one gets a little trickier, right? And I think that we honestly probably didn't do too much of it in class. Wait, hold on, what's wrong? Okay, construct a confidence interval appropriate for the hypothesis test, right? What's the confidence? So let's go out of here. And we're gonna look at what we're doing. The only thing that we really need to do is calculate E, right? And we calculate E based on an equation. I actually don't have it right here. That's interesting. Let me go look at this. Yeah, I probably wouldn't have it in my homework. There's no reason. But as I told you, this is what I circled way, way earlier with y'all, right? When I sat back and said that the standard error is pretty much the same thing. It's in both of these equations.
While you're looking for that, can I tell you something funny?
Yep, go right ahead.
I don't know if you could tell, but all my animals were in the camera. My roommate's been gone all weekend and I forgot to feed them. That's not funny, but I think that's funny.
Well, you know what? They're still alive, and I'm sure you can remedy that issue.
I feel bad. Okay, I'm over it now.
You know what? As long as you don't tell me that if I see you tomorrow in stats class, I can just be like, yeah, they still haven't eaten. But
well, no, that's why I got up. I fed them when I remembered.
Okay. All right. So this right here is the equation. E equals, now again, let me blow this up so we can all see it. We got to calculate the margin of error. And we do that by getting T critical, which we've already done, right? And then we're going to solve the math right here with this equation, which essentially we've kind of already done too, right? But we're going to, we'll do it separately right here so I guess the class can see it. Now, when you get this margin of error, that's when you're able to, calculate the confidence interval. So what you'll do is you'll take the mean of x of 1 minus x of 2, and those numbers are given to us in that yellow table. And then we'll subtract our margin of error from it, right? And then we'll take that same value and then we'll add the margin of error to it. And essentially what we're doing when we do that is we're creating our wiggle room. Remember how I sat back and said, look, we're going to take the blue background and the red background, right? And we get a certain value. And then this margin of error, this is literally like, again, I think the word margin of error, I usually like to use the word wiggle room, right? But what's the wiggle room that we would say, all right, it might be a little bit off. Like Siani is 19.3 years age. Naris is 19.9 years of age. What's the cutoff that we will say it's significant? We figure that cutoff by calculating this wiggle room. And essentially what we do is we will subtract the wiggle room, and then we'll also add the wiggle room. And that's what gives us our confidence interval. We subtract the wiggle room and we add the wiggle room. So it's almost like saying, I'll use what I said before with Naris and Siani. I said 19.6, and then we said 19.3 is probably what I've used, right?
Yes.
So 0 is right here, but you do that, they are negative 0.6 apart. We are essentially going to create a wiggle room this way by adding E, and we're going to figure out what our wiggle room this way by subtracting E. And when we do that, that's how we figure out and we do our confidence interval. This whole area right here will be our confidence interval. And if that confidence interval includes 0, then y'all the same age. I need to stop sweating a couple of months out of the year. If this confidence interval does not include 0, then yeah, it's a significant difference. And somebody gets to claim they're older than the other person and be like, be quiet, shut up, I'm talking. You know, kind of like a hierarchy. Put it down, stop. My dog goes into the laundry room and gets my kids' dirty underwear when he don't think anybody is looking and goes and chew on it.
My dog does the same thing, but he hides it. We found a pile. Every time we give him food and he doesn't want to like eat it and doesn't want to make us feel bad, he'll hide it under the couch, and he's been hiding the underwear too.
Wow. Yeah, I'm glad. I thought my dog was crazy, but apparently he's just like everybody else. All right, so I'm going to erase this. All right, guys, so let's look at what we've done. I remember what the T critical is. the equation that we have is that kind of T critical, which is T alpha, multiplied by the square root of S sub 1 squared plus S sub 2 squared divided by N sub 1 divided by N sub 2. Now, again, this information right here gives us all the information that we need. So let's recreate this. We know what T alpha is. That is 2.032. And actually, this is for E. I just want to make sure we understand. Right now, we're only calculating that wiggle room, that margin of error. We got the square root. S sub 1 equals 5.9 squared divided by 35 plus 5.48 squared divided by 36. Now, I could go through and do all the math. However, I want to be mindful of your time unless somebody wants me to go do it. And definitely tell me if you want me to. But if we get out of here and go look at what I have already given you in the homework, annotate the math for that is already here.
And this is the document you emailed us, right?
Yes, I emailed this to you. Yep. Now, again, this is only part of it because what we just did right now is we only calculated E, right? So that's part of the issue, right? Now, what we did is this. We also calculated what our E, our wiggle room is 2.747. I mentioned before, we're going to subtract that from the difference and we're going to add that to the difference. What might not be clear to everybody is where this came from. Where did this 3.5, ooh, that's an ugly color. Where did this 3.58 come from? And where did this 3.58 come from? These two values came from the difference between those two means that were given to us originally. And I'll go back and show you guys what I mean. Talking about this number right here. Oh, this is not the homework. We'll get there, hold on. I think it's the next page, but let me go down. I don't want to waste time.
Dr. Barnes,
Yep.
I have a question. It's, I mean, never mind. It can wait until after we're done going over this.
Okay. I'm going to show y'all where we get this answers from. Let's take the 15.89, which we get from this table, which is this right here. I'm going to subtract that from 12.31. And that should give us exactly what was on that other page. Oh, my phone's not with me. Can one of y'all do the math and find out what that number is?
Yes, sir.
I did all this without needing a calculator. That's crazy.
That's just you being Dr. Barnes.
Y'all with me too, though. So y'all right there.
3.58.
3.58. 3.58.
Which is good.
Right? And that's exactly what I think I have on this form. 3.58. We found out E, which is our wiggle room, we subtracted E from our difference, which gave us the low end of the confidence interval. And I'm gonna recreate it right now if I can, right? So the low end of our confidence interval is 3.58 minus this, which gives us a value of 0.833, right? And then we take this and we add that, gives the upper end of our confidence interval. And that gives the value of 6.327. 6.237. Same thing. Let me draw this. Our confidence interval is here. And the only thing we got to do is look at this confidence interval and ask ourselves, is 0 in the confidence interval? It is not. And since it's not, then look, based off what we have, yeah, they are significantly different from each other. Because when we subtract them and then we add in our little wiggle room, it doesn't include 0. So those things are really different. I mean, not just a little bit different, not just like Narice and Siani, 6 months older than each other out of the spectrum of their entire life. No. They are significantly different from each other. And that's because the difference that we calculated plus our wiggle room does not include 0. If it did include 0, then we would probably say, yes, it does. They are the same. Now I could do 10, but I'll tell you 10 is exactly the same. It's just 8 and 10 were identical. This is what I want to do. I want to make sure that you guys can kind of write on the screen just a little bit. I'm gonna make some breakout rooms.
There's only 4 of us.
Yeah, and I'll make 4 breakout rooms.
You're gonna put me in a room by myself?
Yes, and let me tell you why I'm gonna put you in a room by yourself, right? Because when I'm gonna put you in a room by yourself, I want you guys to get on your device, and I want you to, let me see. I want you to solve, let's just do this. The math required for this right here. Let's clear this. I want y'all to try to do the math that allows you to solve this equation right here based on these numbers. I want you to do that using the annotate feature in Zoom. Now, let me tell you, it takes a little while for me to get to where I am, whether in your mouse, whether you're using your finger or whatever, but I just want y'all to kind of go through kind of solving this equation right here with these numbers on your device, just to see if you're comfortable doing it. And it will get better, a couple different steps, just have a little issue. It's not going to look good the first time you do it, but I think this is great to give you a little bit of practice, some visual confirmation as soon as you, before you're messing with them. So in the event that you do have to write on the screen to help them understand something, you'll already know whether you're good or you're bad. And I'll tell you, I think solving these problems will make you even better as a result of doing it. Now, what I'm going to do is this. I can email this to you. I'm going to email this slide. Wait, hold on.
Hold on, Bobby. Where did you go?
I'm going to email this slide to each of you. And I'm also going to email the equation. So the equation is on the screen. I want you to have to like go back and forth and do certain things. What is going on? Um, I must be in the wrong chapter.
Cleveland, no, come here. What are you doing? Leave her alone. You know she doesn't like you.
Yeah, how did that happen? All right, so I'm going to have create a slide for you. We'll have this. Go to paint.
Dr. Barnes,
Yep.
do you still think we'll be done at 3:30? I work at 4.
Yes, I definitely think we will. I am going. Ooh, what's going on? Oh, wrong. I got a new flash drive. Yes, we will. And I will make sure of it. And actually, you probably will be done before that if you, depending on how quickly you can kind of do this math on your own.
I don't think I'm worried about the math. I think I'm worried about the writing on the screen.
And and that's what I mean. That's what I mean. Not like sort of like making the math right, because the math's almost already shared with you, right?
Yeah.
Essence of statistics. That's what I call it. EOS. All right, so I'm going to email this to both of y'all. So no, all three of y'all, I'm sorry. And just try to go into the breakout room, open up this document. And if you open it up, if you do it in the PowerPoint, right, it'll be mostly blank screen. If you go to the annotate feature in each of your breakout rooms, I believe you guys should be able to draw on there and just try to work on it and give it like a 9-minute try. Come back to me, let me know how it worked, and then we'll go there.
How do we leave? How do we come back to you out of the breakout room?
You know what? There's a button in there, I think. You know how you usually exit Zoom and it's like the leave button? Sometimes it's you go in there and it's like a leave breakout room, I think it says.
Okay.
Yanni Goodman and Amber Young.
Cleveland. No, I knew. Shut up. Cleveland. Oh my gosh. He's the worst guard dog because he barks like that until they get in the house. And then once they're in the house, he stops.
Now my dog and your dog. All right, I'm pressing send right now. It should be in your inboxes. I'll give y'all a quick rundown on, I guess, what it looks like. Oh yeah, all on the screen. What it looks like when you do it. There's usually that Zoom bar. And if you do the share screen, right, in your own little Zoom room where you're in, it'll go to the PowerPoint, you'll be able to open up that slide. And then off to the side, there should be a button that says annotate. And when you go to annotate, when you open that up, it's a lot of additional features. And it should allow you to do what you need in the breakout rooms. So I want to let y'all know, the breakout rooms I think are already open. I will jump into everyone's breakout room just to make sure you're all right and help you. I don't want anyone to be stressed out. I'll just go up in there and try to help you move around. And yeah, thank you guys so much. Oh, the only thing I would probably say now is this. looking at the problems that we're going to do, we got problem 1, which is the dependent look at this. Problem 1, which is the dependent dependence, whether it's independent and dependent samples, right? We got problem 2, which is talking about how to understand a confidence interval and then how to write one. Then we have 3, which is highlighting that part of the textbook that says that it's, equivalent methods, and then maybe pointing out that the standard of errors are identical, right? And then answering problems 8, 8A, 8B, and that's it. I'm not going to worry about 8C. How would you guys like to break this up tomorrow in terms of who's going to do what, and like maybe in groups, piggybacking off each other? How would you guys like to that part of it? I sent the email, but everybody didn't come here today.
Sorry. Maybe we could each do like 3. Is there enough for, or 4? Maybe the 3 of us could split into 4 problems.
No problem. I'm going to sit back and see what that looks like. All right.
Amber, Siani, is that cool with you guys?
Yeah, that's fine.
Do you guys
Yeah.
have problems you want? Because I don't care. Please don't give me both 8 and 10 though.
No, we're not going to do 10. We're not going to do 10. We're just,
we're not doing 10?
Yeah, 8. If we go over what we're supposed to do for we go over what we're supposed to do for 8, there's no reason for having to do that, to go into it. So it's not that many problems amongst you. Now I want y'all to know that they're not all created equal. You know what I mean? So maybe if y'all want to tag team or whatever, but I just want to kind of get this list just to make sure that you guys know where to focus your energies.
I can do my original problems, 2A and B and 8A and anything else if need be.
All right, so 2A and 2B, is that what you're saying?
Yeah, and I can do 8A.
And 8A. Okay. Anybody want to take a stab at the dependent samples, which they were kind of tricky?
I can do that.
All right, Amber. Okay. Then we're dealing with the 2 different types of how they're equivalent.
I can do 8B.
8B, okay.
I'll do 3B and 3A.
Okay, guys, that is excellent. The breakout rooms are there. We're really close up on being 3:30. So you guys go in there. I'll try to jump in, and you guys can come back out if you're feeling like you already got it and you're comfortable with it. But if I could be of any help, I'll be here for, I don't have anywhere to go, but you guys can give me a 4-minute try on doing that with the PowerPoint so you can be a little bit comfortable. I think that'll make you guys in great shape. All right, you got, are the breakout rooms there? Y'all can jump in them?
I can't see the breakout rooms on my end.
Oh, okay. You know what? I don't think I officially opened them. I'm opening them now. Chico, cut it out. All right, Naris. Now you're muted. When you jump into another room, you're usually muted.
Sorry, Dr. Barnes. I have to open the whiteboard, right?
You know what? There, you can open a whiteboard if you want to. However, the PowerPoint that I emailed you, that I think if you go to the PowerPoint and then you open up the slide, that will be best. But you could use the whiteboard.
Wait, can you see? What do you see?
I'm all up in your email.
Okay. Okay. And then, okay. Open. Okay. It's opening. Oh, okay. And then just Oh, I opened it too many times. Oh Lord. Oh Lord. Oh Lord. Oh no. How do I? Oh
I don't know how to stop y'all from doing that.
no. Okay. And then where's the tool to write?
All right, now here's the thing. I can't see your PowerPoint. Are you in your PowerPoint?
Isn't oh
I'm stealing your email. I'm stealing your email.
what? How are you still in the email?
So go back and do a new share. Like when you go to when you do a share screen, there's a couple ways to do it. A lot of people will like,
Dr. Barnes, I'm not even gonna lie. I don't know where your voice is coming from. I don't know where you are. I think
that's fine. You can't see my picture anyway. I'm not showing my picture.
I don't know where the Zoom is.
Screen
is
share
this
button.
Is this where you are? Do you see this?
Yeah, I see that. Yep.
Okay. 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 I just gotta go back to Zoom now. This is stressing me out. Oh, right here. Resume share, stop share, screen share. And then I want to go here, share.
Yep.
Okay. Is that right?
Yep. And
Okay.
when you make this a presentation, all that white space, you know what I mean? And think about it. The reason why I like this is because this white space has the numbers that you need and the equation that you need.
How do I make it a presentation?
I don't know.
Dr. Barnes.
Go to the one that says view, the very first one. Or press play. Press the play button.
Oh, okay.
All right. And then go into the, do you see the Zoom bar?
Do I see what?
The Zoom bar, like, it's like a little menu bar. It's like probably in your way when you're
Yes.
screen. Now, if you go to that and look over to your right, you'll see something that says annotate.
Yes. And then do I click the mouse? No.
You click the option that says draw.
Okay. This is like type. Okay, I don't know what I clicked. Oh, that's not right.
Well, I think you're creating shapes. Don't do that. Go to options that have like draw.
I am in draw. It's just I can't see like my mouse for some reason, so I just see where it's hovering over. Okay.
Play around with the other one because I think there's one that even when you go and draw, I think there's like a squiggly line. You see like the things like the first two are squiggly lines.
Yes.
That will allow you to like write, like you could like write your name.
Okay. Okay, did I click it? Oh, that's not the right thing still. How?
Again, go back in.
You make this seem so easy. Can I stop doing that for a second?
Yep.
And then try again. So this is where I'm at, share screen. Draw. Okay, then you go to annotate, then you go to draw, then you go to this.
There you go. Now, right above that, if you go back in and see which one is highlighted, right above that is a thing that looks just like it, but it's a little narrower. That's the one that you really, there you go.
Okay.
There you go. Have all your fun. You're writing your name. You could.
I'm trying to write my name.
And you know what? For you, Nyrese, keep mindful of your time because it's 3:32.
Oh, okay.
3:32.
Well, I at least want to master my name. Why is it so hard?
I'm going to go jump in other people's room. I think you got it. I can't make your handwriting get any better on Zoom. Make sure you understand the features.
Thank you, Dr. Barnes.
I think tomorrow's going to go really well.
I will see you then.
All right. Bye.
Goodbye.
Oh my goodness. There goes Siani again. Look at you showing off.
I'm struggling a little.
It's a little crazy, but yeah, you got it. Now I'm going to take off and go make sure Amber's okay. Is there any concerns or any questions you have?
No.
All right. Thank you so much, Shiani. Now, let me ask you, what did you get on the homework? I know somebody got like something out of 19, like a 19 out of 19. What did you get on it?
Um, I haven't checked my score. I can check it now.
No, don't stress it. Don't stress it. I just want to make sure it's worth it. I know out of the 5 people I emailed, like some people had really high scores. One person only got like 1 item wrong. So I was just wondering, like maybe they won't show up. I thought it was either you or I'm not gonna say the other person, but I thought it might have been you. But no biggie. You're here. You guys know what you guys are going to be doing tomorrow. I will probably be there just to kind of support you, but I'm going to be in another meeting, so I won't be able to be like super hovering. But I think you guys are going to do a great job.
Okay.
All right. Let me go make sure Amber's good. Look out, look who doing her thing.
Does it look okay? I know it looks a little sloppy.
You know what? Let me tell you, if you were to sit back and evaluate me, you know mine look a little sloppy too. And you know what? I tell you, I don't even think it's a situation of it looking good, because especially if you talk through it, you know what I mean, in terms of what you're doing. But I just wanted to make sure you knew where the menus were, to knew what it was, and yeah, this is more than good.
Okay. Should I keep going or?
No, honestly, I think you've done more than enough. If I wasn't in the other rooms, taking as much time as I needed to, I would have been back earlier. But some people try to get the bars and stuff. So that looks great. Only thing I would say is go over some practice, make sure you're comfortable with it. I'll be there. I don't know how vocal I'll be able to be when I'm in the room, because I'm going to be in another meeting, right? That comes the Monday time, but I will be there. And I think if y'all say something like, Dr. Barnes, I need help, I'll jump out of the other meeting and help y'all.
Okay, thank you.
All right, Amber, I'll see you tomorrow. And thank you guys so much for everything you guys are doing.
You're welcome. Thank you.
No problem.
All right,
Hey, what did you get on the prom? Are you the one that got like almost 100%?
No, I got like a 57 or 58.
Okay.
But I know exactly where I went wrong. Like, I think I was just overthinking everything, honestly.
Yeah.
Especially with the first problem with the dependent and independent. Like I was just overthinking everything.
No, let me tell you, I am embarrassed about how that first problem worked out, because yeah, it trust me, when everything I said, I know I ramble sometimes, but I really mean it. That was a mean problem that the author of the book did. And yeah, I don't even know how you would teach people that. Honestly, it would be neat in my experimental class to give these to all the psych faculty members or all the faculty in social sciences, right? And just see what we do if we think it's an independent or dependent. Let me tell you, I think our faculty would be messed up on that. That was real grimy.
Yeah.
Don't worry or apologize. You guys are doing great. Issues about learning, and you guys showed up for this, so you guys will be fine.
Okay. Thank you so much. Enjoy the rest of your day.
Sure will. Bye.